know. We are live. Kill him. Good day. Welcome once again to yet another session for mathematics. As always, we would be treating past questions from previous years of the UTME as well as theoretical exams to have a feel of how the mathematics exam is set, the different topics that exist within each exam, as well as how to answer the questions you come across. Now, do not forget, the most important thing is to solve as quickly as possible. Make sure you get the right answers as efficiently as possible and have the ability to move on to the next question without worrying if your solutions are right or wrong, which means that at the end of the day, you have to have trust in your structures and techniques, and that can only come from practice. And this is what we have been doing from the start of class early in the year. Now, for today, just like in other days, we would pick questions from past questions from across different years to allow us look at a wide range of topics. While we pick the question, we will discuss the parameters necessary from the topics as well as discuss on how to solve the question correctly. So that would be our modus operandi for today. So let's begin. First and foremost, let us start with a matrix question. Now, to solve this, first and foremost, what we need to think about is this straight lines here represent the fact that we have to look for the determinant of this 3 by 3 matrix. Now, how do you look for the determinant? You first and foremost start from this value here, and then you cut across and create a 2 by 2 matrix whereby you would multiply the determinant. Essentially, in this case, you're seeing the determinant is equal to 0 multiplied by 7 times 4 minus 8 times 5 minus 3. Now, from 3, you can also formulate its own rules. So you have 1084 as a 2 by 2. So you have 1 times 4 minus 8 times 0, then plus 2, which will give you this 2 by 2 here. You have 1 times 5 minus 7 times 0, which would mean, of course, this is going to be 0 minus 3 times 4 plus 2 times 5. And that will give you minus 3 times 4 is minus 12 plus 10. That will give you minus 2. So it means that the determinant for this 3 by 3 matrix is in fact minus 2. So essentially, from the topic which is matrix and determinants, you'd find out that the basis here is first and foremost identify what dimensions it has. In this case, a 3 by 3 square matrix, which means that by finding the determinant, you find it with respect to the rows and the columns at all times. So that is the key to solving this particular question. Let's move on. Next, so in this case, you have to find the midpoint of two points that have been joined together to form a line. So this is line geometry. Now, S is a point at minus 5 and 4, and then T is a point at minus 3, minus 2. They are joining together to form a line, a straight line, of course. And then we have to find the midpoint of that straight line that joins these 2 points. Now, do not forget that for if you have x1, y1, and then x2, y2 as 2 point coordinates, then the midpoint is simply going to be point at x1 plus x2 over 2, and then y1 plus y2 over 2. So essentially, in this case, the midpoint of S and T is going to simply be minus 5 minus 3. Those are x1 and x2. So that will be minus 5 plus minus 3 divided by 2. And then you have 4 plus minus 2 divided by 2. So the midpoint ST would now be minus 5 minus 3, that's minus 8 divided by 2, that's minus 4. And then 4 minus 2, that's 2 divided by 2, that is 1. So the midpoint of the line joining S at minus 5 and 4 and T at minus 3 and minus 2 is in fact minus 4 and 1. So if you draw the line, you expect that once you reach the half point, the coordinate at that point should be minus 4 and 1. So, of course, this shows you the range of values that you can have in your O-level exams. Let's check another one. So here we have it. Says y varies directly as w squared. When y equals 8, w equals 2. So we have to find y when w equals 3. Now, when you say y varies directly, that means we're saying that we are considering a direct variation question or a direct proportion question. Now, what the direct variation tells you is that an increase in one parameter causes a corresponding increase in the second parameter. So it's an increase scenario. An increase in one parameter causes a direct increase in another parameter. Now, so it means that for here we have that y is 8, w is 2. Find y when w is 3. Now, w has increased from 2 to 3. So we expect the y values to also increase from 8 to something bigger than 8, right? So that's a quick hint before you even start solving the questions. Of course, there are different other kinds of variations that we have looked at in the course of our classes. You have yourself the inverse variation, which tells you that an increase in one parameter corresponds to a decrease in the other parameter. So while one is increasing, the other one is decreasing. You also have your mixed variation, which is simply a combination of the direct variation and the inverse variation. And then you have your partial variation, where in this case you are saying that one variable is partly constant and then partly varies with respect to another variable or two or more variables. So in this case, it could partly vary directly or partly vary indirectly, which is inversely. And then you also do not forget that you also have the joint variation, which is this time around you combining two or more variation concepts into one single question. So you can say y varies jointly as u and v, y varies directly as u, and then partially constant to v, depending on how you want to write your question, as the case might be. This, of course, we have looked at it in our previous classes. You can always check through our recordings to find more on that. Make sure to also share this with your friends so that they have the opportunity to learn as well. Now, let us solve this particular question. Y varies directly as w squared. This alpha sign is called the variation symbol. Now, whenever you remove the variation symbol, a variation constant is formed, or you call it constant of proportionality. Now, removing the alpha sign puts the equal to and a constant in its place. So exactly where the alpha was, it's replaced by an equality sign and a constant of proportionality. Now, your first goal is to find what value that constant of proportionality has. So in this case, for the first parameters, we have that y equals 8 and w equals 2. So if I use that, do not forget that if I make case of the formula from here, k will be equal to y over w squared, which would mean that k is equal to 8 over 2 squared. 2 squared is 4, so that means that k is equal to 2. So if k is equal to 2, we are now to find y when w equals 3. So don't forget that y is equal to k w squared, which means that y will now be equal to k, which is 2, times 3 squared, since w is 3. And that would mean that y will be equal to 2 times 9, which would mean that y is equal to 18. So what does that immediately tell you? It tells you that as w increased from 2 to 3, y also increased from 8 to 18, right? So that's how a direct variation works. A corresponding increase is most definite. Once one variable increases, the other variable has to increase. Which means that if you are solving a direct variation question and then one variable is increasing and the second variable is decreasing, then you should know that there's something wrong with the formula you're using. You're probably using the formula for the inverse variation. That is something that you must check to confirm. So let us move on to another branch. So we have looked at matrices and determinants. We've looked at line geometry. We have also looked at variation. So that tells us immediately that, of course, there is a lot of concepts that Jamb, Waec, Neco, GC can use to ask your questions. Over the course of the last few weeks, we have looked at questions around these three, of course, I've also looked at sequence and series. We have also looked at two-dimensional shapes, three-dimensional shapes, as well as arithmetic progression, that's geometric progression as well, and a whole host of other topics as well. Of course, indices, logarithms have also emerged. We have also had error calculation, error analysis also come into play. So there is no limit to how exactly questions can be coined. This is why it's important for you to practice all the time. Practice makes perfection, which means that the more you practice, the more you are shown to the world of the topics that can be used to set questions. Then you familiarize yourself with those topics and improve your chances. So let's continue. So the question is, in how many ways can the letter in a word elation be arranged, right? In how many ways can the letters in the word elation be arranged? So, of course, this still falls in the permutation and select and combination parts of mathematics. But in this case, you are not necessarily going deeply into permutations in terms of the formula. Don't forget that formula for permutation says NPR is equal to n factorial divided by n minus r factorial. But in this case, you just need a bit of that formula. Now, we are saying how many ways can the letters in the word elation be arranged? Now, the very first thing you want to do is how many letters are in the word? You have a total of 7 letters in the word. Now, are there duplicates within this word, which means is there a letter that appears more than once? So in this case, E appears just once, L appears just once, A once, T once, I once, O once, and then N once. So since there is no duplicate, the number of ways will simply be 7 factorial. So of course, you can go ahead to then use your calculator to determine what the value of 7 factorial is. And if you don't have your calculator, you can always know that 7 factorial is the same as 7 times 6 times 5 times 4 times 3 times 2 times 1. So you can then multiply this to see what your answer be. To make it a little bit easier for you, 7 times 6 is 42. So you have times 20, which is 5 times 4 times 6. So this is going to be 42 times 120, right? So you can go ahead to bring this down as much as possible. But if you would like, you can also clear out your maths and write it as 40 plus 2 times 120. So this would be 4,800 plus 240. And you see that we're already at the answer. So this is just going to be 50, 40 ways. So 5,040 ways exactly can be used to arrange the letters in the word elation. So I can rearrange the word elation in 5,040 ways using the letters there, right? So in a quick note, if there were any duplicates within this letter, then you divide by the factorial of the amount of times those duplicates occur. Let me give you an example. For instance, if you have the word to be facade. Now, in this case, you have a 6-lettered word, so that's 6 factorial. But then you have A occurring twice, so that will be divided by 2 factorial. So the word that occurs more than once, you divide by the factorial of that number of times it occurs. For instance, if you have a word like banana, Now, in this case, you have yourself another six-lettered word, but now A occurs 3 times and then N occurs twice. So that's how you write it. So this would, of course, give you 6 times 5 times 4 times 3. And then this would, of course, give you 6 times 5 times 4 divided by 2, which is 6 times 5 times 2 ways. So essentially, if a letter is repeated more than once, number of times that letter is repeated comes to the denominator and divides the total number of letters you have, right? So, but in this case of elation, there is no repeated letter, so you will just have 7 factorial. So it's just like saying 7 factorial divided by 1 factorial, 1 factorial, 1 factorial, 1 factorial, 1 factorial, 1 factorial, 1 factorial. So that's just divided by 1. So that's why you still have it as 7 factorial. So this is exactly how an arrangement question would look like, of course. Then let's proceed. We can also have Q5. Let's look at yet another question. So we have to evaluate the integral of sine 2x dx. So this is an integration question. Now, in this place, you can just simply use the method of algebraic substitution for integration. So in this case, we know that the integral of sine is a standard integral. However, the angle is not a standard angle. So by algebraic substitution, I'll say let u be equal to 2x, so that my integral of sine 2x can change. Now, for this to change, I also need to find the value of dx, but then I know that du will be equal to 2 dx by differentiating this, both sides. So it means that dx will be equal to du over 2. So if I impute all of this here, I'll have integral of sine u, then dx will be du over 2. So this becomes 1 over 2 the integral of sine u du. But the integral of sine u is a standard integral that is going to give me minus cos u. So that will be minus 1 over 2 cos u. And then plus c, right? So in this case, don't forget that my u is 2x. So that's like saying minus 1 over 2 cos 2x plus c. And that will be all. So don't forget the constant of integration has to be added every single time you integrate an unbounded integral, right? This is an unbounded integral, which means there's no lower bound and no upper bound. So whenever you integrate an unbounded integral, a constant of integration must be added. Now, you can either use your constant of integration to be c, or you can use your constant of integration to be k. That depends on you, right? So if you have in your options, in your past questions, and you see it as minus 1 over 2 cos 2x plus k, don't be worried. K, C, they are still constants of integration, right? For unbounded integrals. However, if the integral is bounded, there would be no constant of integration. Why? Because you would have introduced the bound while solving the question, right? You would have introduced the bound while solving the question. So that would effectively eliminate the constant of integration, right? So let us move on to our next question. So we have to factorize ax minus by minus ay plus bx. Now this is of course under polynomial and factorizations of those polynomials. In this case, this is a linear polynomial because all the variables I have here, the highest power on them is 1. So it's a linear polynomial. Now we have to factorize this. In factorizing this, the biggest hint here is to factorize based on a common variable. Now, what you decide to use as your common variable is left to you, so long as you are able to factorize based on common variables. Also, make sure you are also factorizing in pairs. Make sure you're also factorizing in pairs. That is essentially very, very important. So in this case, you have ax minus by minus ay plus bx. And that, in this case, if I choose to factorize by a, then I can group them by a's and by b's. So I'll have ax minus ay plus bx minus by. And now a can be factorized out here. I'll have x minus y left. And then b can be factorized in those two. I'll have x minus y left. Then x minus y is common in both sides, so I can factorize that. And what I'll be left here is a, and then what I'll be left here is what? B. So the factorization is x minus y, a plus b. Now you might be wondering, what if I factorized it without using a and b? I used x and y at the start. You will still arrive at the same thing. What that means is, instead of having this, let's say you factorize with respect to x and y. So if that's the case, you have ax plus bx minus by minus ay. This would factorize x for you into a plus b, and this will factorize minus y for you into a plus b, or b plus a, anyone you like. A plus b is still common, so it comes out that you'll be left with x minus y in the bracket. So you see that regardless of any one you decide to use, you would still end up at the same factorization, right? You would only be having different factorizations if you failed to take note of the signs, because that's the biggest problem students always have whenever they are carrying out factorization. How to correctly look at the signs and choose the right representation for the signs. It's not just enough for you to be able to solve the question. It's important for you to be able to use the signs correctly as I when due. This is very, very important. So that answers our question. Let's move on. So we have, if the angle of a sector of a circle with radius 10.5 centimeters is 120 degrees, find the perimeter of the sector, take pi to be 22/7. The angle of the sector being 120 degrees tells us that that sector is in fact the minor sector. The minor sector. Now that's very, very important. Remember that the minor sector is a sector whose angle subtended at the center is less than 180 degrees. Once the angle is less than 180 degrees, it gives you a minor sector. Keep that in mind. So if this is the minor sector, then it follows that the most important thing to work towards is finding out the formula needed for the perimeter of the sector. Now, do not forget that perimeter of a sector is simply the addition of the two radii that bound to the sector and then the length of the arc that conjoins that radii to create the sector in between. So it's just a single piece of the pie, right? So it has two radii and then the length of arc or the arc which bounds it, which is also, by the way, the minor arc. So by extension, you have 2r, which represents the addition of the two radii plus theta over 360 times 2 pi r, which is the length of the arc, right? And it's, of course, a portion of the circumference of the circle. The length of the arc is a portion of the circumference of the circle. Don't forget that circumference of the circle is 2 pi r, which is the entire circle. So if you take theta over 360 of that circumference, you'll be looking at the length of the minor arc, which is very, very important to keep in mind. So in this case, the perimeter is going to be 2 times 10.5 plus 120 over 360 times 2 times 22 over 7, which is what the question asked us to use, times 10.5. So, of course, by extension, multiplying this all together, you have 10.5 times 2, that will give you 21. Plus, this is 1 over 3 times 21. That's 2 times 10.5 times 22 over 7. So 7 cancels here, you have 3. 3 cancels here, you have 3. So you are left with 21 plus 22, which gives you 43 centimeters, right? 43 centimeters. Now you have been wondering, or you, of course, have been thinking in your head that I had to press the calculator at this point. Well, that's where the trick is. Jamb wants you to spend as much time as possible to take this to your calculator and say you want to be multiplying 2 times 22 times 10.5 divided by 7, because in your head you expect it to be a decimal because this is 10.5 as a decimal. However, from the length of the radii, which is 2 times 10.5, you should already see a pattern. If 2 times 10.5 is not giving you a decimal, which is 21, then you should know that 2 times 10.5 here will also not give you a decimal, it will give you 21. And 21 over 7 will give you 3. That is essentially why they told you to take pi as 22 over 7, because you're like, if the radius is already 10.5, why not just take pi to be 3.142, which is also decimal, so you just have decimals everywhere. However, they knew that by taking pi as 22 over 7, everything cancels out easily to just leave you with 22 in the middle of that division. So 10.5 and 7 cannot obviously divide. 2 cannot obviously divide 7. However, 2 times 10.5, which gives you 21, will then be divided or divisible by 7 to give 3. Then that 3 cancels out on this side. So always note this, regardless of whatever the question seems like. Always note that whatever you come across in an objective-based exam would always be questions that have been created in such a way that you use the smallest amount of time possible solving it. Remember, as far as your exams are concerned, the student is expected to spend 3 times the time the examiner spent creating the marking guide for that question. So if the examiner could solve that question in 15 seconds, it's expected that the student answering that exam should be able to solve that question in 45 seconds. Now, the ideal will now be to extend that into 4 times, which is the exam board will now create an avenue where you have 4 times the time, or sometimes even 5 times the time, to be able to solve that particular question. So it means that if you see a question in an objective-based exam and it's taking you a minute, best believe that it's going to be taking your examiner 15 seconds or less to solve that. Because if it's taking you a minute, you probably are not the fastest person solving in that hall. So if the fastest person in that hall could solve it in 30 minutes, that means that the examiner can solve it in well lesser than 10 seconds, right? 30 seconds, well less than 10 seconds. So it's important to be able to keep that in mind and also solve and improve your speed based on that. and your speed can only increase based on practice and practice, right? So let's move on and check another question. Of course, do not forget that all the questions I've checked so far have come from distinctly different topics to tell you how wide the pool of questions is for these exams that you plan to write. Whether it's the objective-based exam Jamb or it's the objective and theory-based exam Waec, GC, or Neco. So do not belittle any part of a question. So you have, if the endpoint of one side of square RSTU are R minus 1 minus 1 and S 3 minus 1, find the area of the square. Now, do not mess it up. The endpoint of one side of the square, which is the top point of that line that forms the side of the square, and then the bottom point of that line that forms the side of the square. Or it could be the leftmost point of the line that forms that side of the square to the rightmost point, right? So it's either you're taking from here to here and then the line is in between, or you're taking from here to here and then the line is in between. That is what the question is asking from. Now, in this case, the endpoints chosen are, so if you just show it a little, you have r minus 1 minus 1. The r coordinate specifically is minus 1. So r minus 1 on the x-axis, this is minus 1 here, the point is here. And then 3 for s, the point is here. So it means that the line you're talking about is here. This is the line between r and s. So of course you expect that either the square is up top or down bottom. It doesn't really matter. You don't really care. But this is the side. Now, you have to now use this endpoint to find the area of the square. Simple. All you just have to first and foremost find is find the distance between these 2 points. And because you know that the square has equal sides, the area of the square will now be distance squared, which is essentially what you call length times width, right? So now, what is the distance between the 2 points? Don't forget that r is minus 1 minus 1, and then s is 3 minus 1. So the distance between 2 points tells you square root of x1 minus x2 squared plus y1 minus y2 squared. So this is going to be minus 1 minus 3 squared plus minus 1 minus minus 1 squared. So here you're going to have square root of minus 4 all squared plus 0. Because minus 1 minus minus 1, that's minus 1 plus 1, that's 0. It cancels out. So you'll be left with minus 4 squared, which is square root of 16. And then, which means that d is equal to 4. Now, I'm taking positive 4. Why? Because it's a measure of distance. The measure of distance is always non-negative. The measure of distance is always non-negative, which means it can only be 0 and above. So you have this distance to be 4. So essentially, it tells you that a is equal to 4 squared, which is equal to 16. Right? So it means that if the endpoints are as given in the question, then of course the area would simply be 16 square units, right? 16 square units. So let's move on. Of course, this falls yet again into two-dimensional shapes and line geometry. So to tell you that there's a long array of ways in which questions can be formulated. So right now, let's move on to our next question. So we have that in a right angle triangle, if tan theta is equal to 3 over 4, what is cos theta minus sin theta? So it's a right angle triangle, which means first and foremost, it obeys the rules of SOHCAHTOA. So by the TOA part of SOHCAHTOA, tan theta is going to be opposite over adjacent, which means that, of course, by question, that's 3 over 4, which tells you that the opposite is 3 and then the adjacent is 4. Now, without wasting time, if the opposite is 3 and the adjacent is 4, I remind myself of what we call the Pythagorean triple. So I know that if I have 3 and I have 4, then the completion of the triple has to be 5. Another way, if you don't remember your Pythagorean triple, is to remember your theorem. Remember, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So essentially, c squared will be equal to 3 squared plus 4 squared, which is going to be 9 plus 16, which means that c will be equal to 5 units, hence the Pythagorean triple. A Pythagorean triple is a set of values for the opposite, adjacent, and hypotenuse, such that they are all whole number values. They are all whole number values. Now, it might come so surprising to you that is that really such a hard thing to do? Yes. For the opposite, the adjacent, and the hypotenuse to all be whole number values like this, it is incredibly hard to get. For instance, if you have 1 and 2 as the opposite and adjacent, the hypotenuse will never be a whole number value, right? That will be root 5. 2 and 4, same thing. 2 and 3, same thing. 2 and 5, same thing. The numbers that fall between that criteria between 1 and 10 is 3, 4, and 5. If you extend the criteria to 1 and 20, then you have 3, 4, and 5. You would have 6, 8, and 10. And then, so between 1 and 10, you have 3, 4, 5, and you have 6, 8, 10, right? And then between 1 and 20, you have 3, 4, 5, you have 6, 8, 10, and you have 5, 12, and 13. 5, 12, and 13, right? Of course, you can still have one more, but that would give you an idea of how hard it is to find this Pythagorean triples, right? So it's not something so commonplace, but it's also very good to have like 4 or 5, the first 4 or 5 Pythagorean triples within your fingertips so that you can always use it. But of course, don't forget that the question is not to find the hypotenuse. The question is to find what the value of cos theta minus sin theta would be. Now, cos theta by SOHCAHTOA is adjacent over hypotenuse, and then sin theta is opposite over hypotenuse. So it means that adjacent, which we have gotten to be 4 over hypotenuse, which is 5, then opposite, which is 3 over 5, this will give you 1 over 5. So it means that cos theta minus sin theta is essentially 1 over 5, which completely solves the question exactly how you want it. So, of course, this is very, very interesting. And then let's pick one more question, of course, in yet another topic before we call it a day. So simplify 1 over 2 minus root 3 in the form a plus b root 3. This is a rationalization of solved question. This is a rationalization of solved question. Now, based on this question, the most important thing you need is first and foremost to remove the solved form in the denominator. Remove the solved form in the denominator. Now, how do you do that? Well, pretty simple. If you have 1 over 2 minus root 3, that is expressible as 1 over 2 minus root 3 times the conjugate of this denominator expressed to the power to a fraction that gives you exactly 1. Now, the conjugate of 2 minus root 3 simply just means change the sign directly in front of the solved form. So that's going to give you 2 plus root 3. 2 plus root 3. Now, if you have that, now I will create a multiple or a representation based on this conjugate that gives me 1, because I know that 1 over 2 minus root 3 times 1 is still going to be the same fraction. So essentially, it means that 1 over 2 minus root 3 can be written as 1 over 2 minus root 3 times 1, but I want to write 1 as 2 plus root 3 divided by 2 plus root 3. And now you're going to have this to be 1 times 2 plus root 3, which is 2 plus root 3, divided by 2 minus root 3 times 2 plus root 3. Now don't forget 2 plus root 3, 2 minus root 3, that's essentially, it's like say a minus b, a plus b, right? This is a difference of 2 squares case, and your result is going to be a squared minus b squared. A squared minus b squared. Now, if that is the case, you're going to have 2 plus root 3 divided by a squared. A in this case is 2, so that's going to be 2 squared minus b in this case is root 3, that's going to be root 3 all squared. So essentially, you're going to have 2 plus root 3 divided by 4 minus 3. 4 minus 3. So it means that you'll be having 2 plus root 3 as your final result, because 4 minus 3 is 1. And if you are going specific and say what is A and what is B, it simply means that A is 2 and then B is 1. If you compare this to this, right? A is 2, B is 1. So that tells you first and foremost that while doing sorts, it's not just enough to be able to know that, okay, you can express sorts as a product of perfect squares and use that to simplify and all of that. More importantly, you can also carry out rationalization of sorts, which is simply a method of removing the sort form from the denominator. The goal is to remove the sort form from the denominator, right? Now, doing this essentially means that you are going to have to multiply by the conjugate of the denominator in such a way that its fractional form is exactly 1, because you do not want to make sure, you always want to make sure that the fraction remains balanced, right? This times 1 will still mean the same thing. So if you now write 1 based on the conjugate, you will still have the same fraction back at the end of the day. So you have just written the fraction in its equivalent form. So it means that the equivalent form of 1 over 2 root 3 is 2 plus root 3. So this shows you yet again the number of ways in which questions can pop up in your O-level exams. I've seen questions from matrices and determinants, seen questions from SOCAT2 with trigonometry, seen questions from line geometry, I've seen questions from two-dimensional shapes. We have also looked at questions revolving around 10 different topics today alone. 10 different topics today alone. All of these topics, of course, we have treated them in detail previously in our earlier classes. At this point, your exams, of course, are fast approaching, regardless of any of the exams you're writing. It's important for you to keep up the practice, which means make sure you are solving as many questions as possible on a daily basis. Solving as many questions as possible on a daily basis means you get used to questions more, you get to see the different ways the questions can be set, and you get to see the different kind of topics that can be set in that subject. If you carry out that practice and you consistently solve a lot of past questions daily before your exam, you're definitely going to be ready enough to get the highest marks possible in that subject, which is telling you that this is a tactic that works across all the subjects you're doing in Jamb, whether it is mathematics, English, physics, chemistry, biology, government, literature, any subject whatsoever. So long as you are able to practice consistently and set a milestone of the practice you are putting in and the scores you hope to get. You are not just practicing just so that you can copy the answers from the back. No, you are practicing in such a way that you are consistently aiming for top tier marks. And then where you don't meet it, you are learning from your mistakes, learning from the question, and getting used to the feeling of pressure in terms of not having enough time. If you're able to do this consistently, you are definitely in good hands and you are definitely ready to get the highest marks possible in your exams. This is what we'll be calling off the session for today. Make sure, of course, to keep up your practice. Watch the recordings of the earlier classes we did. Make sure to also like, share, subscribe, send to your friends to also join so that they can also have access to the recordings. Thank you for joining. I hope to see you in our next live session. Bye, guys.